After next. Okay. Class is now in session. Let me give you guys your measurement for today. It's just one sheet, thankfully. There you go. Pass these around. Pass these around. All right. Let's get to the discussion portion. So, we're going to be talking about the volume. So it says, recall the volume of a prism as a product of the area of the base and the height. By the analogy between a prism and a cylinder, the volume of a cylinder is found the same way. So the volume V, whose base has area A and height is H, VE is equal to AH. So there we go. Here's our cylinder. Okay. And it has some height H. So the volume of the cylinder, V, is equal to AH, where A is this right here. It's the area of the base. Equivalently, it would be right here. But you only need to use one area, not two. Because you get this A and you multiply it through the H to get the whole volume. So what is the area A? If this is a radius R, it's a circle. Very good. 5R squared times your H. That's your volume of your cylinder. Okay? So that's how you do that one. Really, this concept is no different than length times width gives you area, except it's three-dimensional. You have a length times another length to give you a volume. Before, you get an area, but now you get a volume. Okay? So let's say you have an associated, so let's say R is in inches. Don't forget your volume will have units inches cubed. Just like areas have inches squared and how lengths have just inches, right? A length is just an inch. Then a volume is inches squared. And then, an area is inches squared, and then a volume is inches cubed. Okay. So next, a standard straw is 25 centimeters long and 4 millimeters in diameter. Okay. How much liquid can be held in a straw at one time? So what will we be kind of calculating in this 64 problem here? Yeah, volume. You'll be finding a volume of liquid. Okay. Because if you calculate the volume of the cylinder, you can figure out how much liquid is in there. So next, find the volume of silver needed to make the napkin ring in the figure below. Again, it's an application of cylinders. That one will be more tricky, so if you have questions, raise your hand and ask me. The 66, the same relation holds between the volume of a prism and the volume of a pyramid. For the volumes of a cylinder and a cone, find the formula above. Use the formula above for the volume of a cylinder and write the formula for the volume of a cone. Okay? So try it out, guys. Try it out. You're going to have to come up with the equation. 67, a cone has a base with diameter 5 inches and height 30 inches. Find its volume. Okay? So we're talking about the volume of a cone here. My hint to you. What would happen if you stuck this cone possibly inside a cylinder? Yeah, I know. We're doing crazy math. Yeah. So, here, hold up. I'll use a different color here.
So like,
Yes, ma'am.
what are we looking for?
Okay, I'm trying to help you understand where the volume of a cone equation comes from. Okay, so notice when I stick this cone inside a cylinder of the same radius. What is the volume of the cylinder? Excellent. This green is running out. Area of the base times height, correct? Okay. So the volume of this whole thing right here is, if this is some radius r, the volume of the whole thing is going to be area times height, which is pi r squared h. The whole thing, including the green and the blue. But what is just the blue? Recall when we did like
You have to find the length of it, the L, and then it's kind of surface area.
Yeah, that's surface area, right? We're talking about volume. That's a good, you're trying to relate it to what you've learned before, and that's really good. I applaud you. But it's that's the surface area of the cone. This is the volume of the cone. So what I want to show you guys visually is how much of the cone, how much of the cylinder is the cone? This is a visual argument. It's not a very rigorous mathematical proof, but you can see visually that the cone occupies 1/3 of the total volume. You guys see that? Doesn't it? Just look at visually. I mean, my drawing is terrible, but if you can kind of like imagine you have a cone and you put it in a cylinder that it has the perfect radius of that cone. Let's say the cylinder was filled with water and you put the cone in there. How much water would get displaced? Only 1/3 of the water, of the total water, original water, would get displaced. So the volume of a cone, yeah.
You square the A?
No.
No.
The A already has a inches squared, millimeters squared, miles squared term in it.
Okay.
So you don't have to square it. It's just this right here. So this is a visual proof of why the volume of a cone is equal to that equation. Pretty cool, huh? Pretty neat. All right.
So I have a question.
Yes, ma'am.
Calculator, could you do A times H over 3?
Absolutely.
Okay.
Yeah, that's the same thing as a. Yep. Very good. Did I just give you an answer? Oh no.
I don't think so.
Oh, okay. Are you supposed to come up with the volume of a cylinder? Or a volume of a cone?
It says find the
Whoops.
volume of-
Maybe I'm feeling magnanimous today.
You can fill that one. Is that a word?
Yes, it is.
Because they say the volume of a prism and the volume of a pyramid, their relationship is the same as the cylinder and the cone, and the volume, the relation between that is that the pyramid is 1/3.
Yes. So that was the hint that would have gotten you here, right?
Yes.
Very good. Very good. I'm so proud of you guys. You guys are just making me filled with joy. Seriously. Math is hard, It takes time to learn it and it takes time to get good at it. But look how far you guys are coming. Just keep it up. Don't give up, okay? Who here popped out the womb knowing how to ride a bike? But who here can ride a bike? Almost everybody, right? What happened when you got on the bike the first few times? You fell. And you scraped your knee and it hurt and you bled. But you were like, dang it, I'm not giving up. Riding this bike seems too fun. So I'm going to get up on it, I'm going to try again. That's really what math is. Except the pain is like in your brain. The pain is up here. Your brain hurts. Okay? It hurts your brain, but it's good for your brain, right? Okay, a cone-shaped paper water cup. Okay, that's just an application of this thing. Ooh, the next page has a very long paragraph. Let's hear Let's hear me read it and let's discuss it. We can investigate the volume of a sphere by imagining that it is filled with a great number of congruent pyramids. Ooh. With apexes at the center of the sphere. What are they talking about here? What are these math nerds talking about? Here's my sphere. Probably the best sphere I've ever made in my life. Okay. So it's talking about congruent pyramids approximating the volume of a sphere. Okay, man, drawing that will be difficult, but this is kind of what they're talking about. Oh man, come on. Like this, actually, maybe like that. Yeah. You guys see that? Yeah, I know. It's trippy. Why am I doing? I'm doing what the problem says. Imagine a sphere. Imagine we can approximate a sphere, its volume, how much volume it takes up, as stuffing it filled with pyramids, with the apexes of the pyramid all at the center. Yeah. I could complete the shape, but it would probably just look more and more confusing. But I hope you guys are starting to appreciate just how beautiful math is. Because look, the sphere is such an amazing shape, and the pyramid is such an amazing shape. And we're utilizing our knowledge of what the volume of a pyramid is to approximate what the volume of a sphere is. Something that's very difficult. It's very difficult to pull this off. Okay? So we're doing that. Number of congruent pyramids with apexes at the center of the sphere. And that the vertices of the base of each pyramid touch the sphere. That's what I have there. These are the vertices. So here's our pyramid, right? This is called the apex. That's what they're referring to, apex. And these are the vertices. Right here, right there, and right there. So that's kind of how I've drawn it out. If the pyramids have very small bases with area B, and the height of each pyramid is nearly equal to the radius r of the sphere. So look, this height h and the radius of the sphere are equivalent. Okay? So the volume of each pyramid is approximately 1/3 BR. What is B?
B?
What is B? What does capital B stand for?
The area of the
Excellent. What does R stand for?
radius.
Yes. Adding the volumes of all the pyramids filling the sphere will approximate the volume of the sphere, right? That's such an ingenious proof of the volume of a sphere. Since the area B of the base of each pyramid is multiplied by 1/3 R, so that the way that is like written is kind of confusing. It says 1/3. It seems like the R is down here, but it's not. The R is up here being multiplied times the 1/3. So the way that's written out is kind of confusing. We can first find the sum of all the bases and then multiply by the common factor 1/3 R. But the sum of all the bases is approximately the surface of the sphere. See? The sum of all the bases, the area of the bases, will then end up becoming the surface area of the sphere. Would you guys not agree? This is where math is so beautiful. Look at what we're doing here. We're creating equations for this, not only for the surface area of a sphere, but also for its volume. This is ridiculous. It's really cool. It's probably why many cultures, ancient cultures, built pyramids. They probably figured out that pyramids are useful in approximating the volume and surface area of a sphere, which is an amazing discovery. The volume of a sphere can be found by multiplying the surface area by 1/3 r. This results in the formulation 1/3 times 4 pi r squared times r gives you 4/3 pi r cubed. So yeah, if this class was asking you to come up with the volume of a sphere, that is when I would say you're going too far. Because that is a pretty difficult proof. And you know what? I believe each and every one of you could have come up with it given enough time. But those ancient mathematicians, you know, they just had all day to think about it, right? So then they came up with it. But each and every one of you could have come up with this as well if you applied it, if you applied yourself and had enough time. You know, they didn't have video games or InstaSnap or TikGram. They didn't have any of that stuff, the social media stuff that distracts you young people these days. Youngians. Then you do the sphere of diameter 3 finds volume, circumference of sphere, find volume, surface area, find the volume. Okay, get to work. You guys don't have one of these? You could have said so. You need 3? You already have a question? They're literally pyramids.
How would you have to draw a base in there, right?
Yeah.
And then, so you have to draw a square and then make all of those lines go to the.
I can see why your brain is like saying this doesn't make sense. Because if you just like were to draw it, it wouldn't look like a sphere. It would look like a really weird jagged shape.
Right.
But what they're saying is, imagine if we stuffed it with infinitely small pyramids. The smaller and smaller the pyramids, the smaller and smaller their bases. Then their bases would get smaller, and then the shape would look more and more smooth. And so then, in the limit, as the number of pyramids approaches infinity, your approximation will go towards 100% accuracy. Yes, both of you.
So, this just explains why that's how you find that.
Yes, that's it.
It has nothing to do.
No, yeah, yes. You don't have to come up with that stuff. It's just really cool. It's just explaining where it comes from. It's just really cool. Yes, ma'am.
Okay, so let's say we got millimeters and centimeters. So we need to transfer them to millimeters.
Absolutely. You need to transfer them to a common unit. You can either make them all millimeters or make them all centimeters.
Also, I have a
Yes, ma'am.
question. For the text, are we going to be allowed to
Sure. Sure. Yeah. What I can do is I can write up all the formulas on the board while you take it. Yeah, why not? I don't want you guys to memorize. I want you guys to understand. I don't want you to spend a second trying to memorize any formula. Yes.
Well, I gotta start because I'm in I guess I'm confused right here. It's
Then you gotta get one by itself. Then you have to divide by 2. That divided by 5. You don't have what pi r
the problem size.
I agree. I love Frozen too. Right.
Get on my.
And then you put it in there.
You can do anything you want.
You put it in. Can you use either one?
Yeah.
Oh.
You can
Did you just whenever you say decimal one place, right? Well, no, there's 10 millimeters. So 25 centimeters would be 10 mils. And we multiply 10 by 25. Yeah. Don't you
If you do five, did you put 5
4.
So what you did was you did the area of this part.
Okay.
So area equals the surface. Then the volume equals that. Because it's just the area of the. I think. I also have.
Yes, ma'am.
Will we be doing our homework in our, like, in classwork?
Yes. On Tuesday, I'll either have it graded, or if it's not fully graded yet, you will get your solutions posted so you can study for the test.
Okay, all right. Well, put that close to Rayla. So we need to fill that.
Yes, ma'am.
It's just saying that it's 2 centimeters. Is it a radius or 2 centimeters plus 5? Like this.
Great question.
Okay.
So you did it out.
Find the volume of cylinder needs to be in there. Can we- So assume that the radius is 2 centimeters, and that small amount of length is that 2 millimeters. Yeah.
Yeah, because this part was 36, it's right.
Oh, you went there?
Or if it was, and the radius is like a meter. Yeah, that's what I'm
Well, I
not. So I think it's, that's right.
Well, I mean, they're right there, that's why I thought you had to.
But in the formula.
When I put 1.69 back, it gives me. I don't know.
I mean, oh my gosh.
The way I did it.
Yeah, no.
I was right. Okay, so 4, 5.
Because you have to, you have
So the
to
radius
change
is
the
three.
25 millimeters to the centimeter.
What is
So
that?
Please. Actually, you're looking. No. You have to find the area of the distance in their service. Yeah.
Yeah, that's my because 36
It is that equation, but you have to find what A is, because A is the area of the
we got, so what I got wrong was to just see what this is.
This is really different.
We got 9.4.
Yeah, is the area, no, it's not pi r gauge.
Where'd you know the 80?
I don't think, because that's like a cone.
Yeah.
That side is. Okay, I think.
Yeah.
It actually
But
does.
it does, yeah, it says pi r squared and then 3. See,
Yeah.
where's the middle?
How else are we supposed to say
Say
that?
like
I'm like, it's formula for 30.
You plugged into this one? I plugged into this one.
It's the same thing. You're supposed to do that the whole line.
See, I did the 36.5, let's see what the decimal
So I
was.
think
Because
actually.
here shows you like your APR, and it's gonna be, I don't know.
Yeah, and then we need to subtract the volume.
V equals AH.
Which is 36.5.
2.2.
Actually, 113. Which is plugged into the calculator. Because it might do 36.5.
Actually, did you watch that?
I did.
They were singing happy birthday, but they only said birthday. So what did you get for the 54? Because 4, so it's 5 times 4 squared. 5 times 2 squared. Yes, that's because we put 4 and that's where diameter.
So I started with the diameter.
So the diameter. So, oh man.
So should be found in those values.
So your diameter is times 2.
We'll do 60 for We'll do 60 for
Yes. Actually, no, I'm just gonna wait on him to ask. 'Cause I don't know. Yeah. Yeah, this is the one that threw me off. That's why I was like,
So we're gonna have to.
we have to do curve, yeah, that's what I was thinking.
Yes, ma'am.
That's like I said, I just did
Because I
it.
started with that area of the base.
So I guess how. Is it 10 millimeters?
One on the bottom, or does that help that?
Okay, so you're doing volumes, right?
So it's 10 millimeters.
Okay, so in volumes, you don't have to add
And there's only 4.
faces because that was like surface area here, surface area here.
Okay.
Because they're flat, areas are flat, so that's why you add the top and bottom. Volume calculates the whole thing. So all you need is just the area of the circle, and then you multiply that
There's only 4
times the height, and
lines.
it gives you the full volume.
There's not even a full set of area. So it's gonna be 0.2.
Use all the data.
Yeah.
I got 3.141.
Yeah.
We got
But honestly,
Here, look. It's the same thing. It's the same thing.
yeah.
same thing you're in.
No, it's, sorry, just 3.2. Sorry.
I got
Oh, so what you can just do is if you do it all in series, then just do this all over.
Are we talking about this I wrote it.
Volume is
I take that and then I multiply it,
Oh, okay.
and then I multiply that by 45. I still get the same thing.
What's this protein?
That's
How do the volume still
converting,
need to make the natural range bigger?
converting, so
You guys
this,
have that with 2 for the radius.
yeah,
So are you finding the whole, like the whole big? I don't know what I'm saying. Are you finding the whole entire big?
You're finding out how much inside.
I remember I was talking to somebody on tutor.com yesterday, he said that's all a cylinder. Anything you run that, because it was a cylinder.
And
Because it's hard to draw very much,
What did you
make you draw.
I never
Well, in the picture,
Yes,
he
ma'am.
said that's what a cylinder
Yes,
was.
ma'am.
But Okay.
Okay.
Okay, so for this one, I'm trying like whole big cylinder.
Okay, no, this guy right here.
Uh-huh.
So it says find the volume of silver needed to make the napkin ring we can figure
You did
below.
like 1 3 times.
I honestly don't know.
Yeah. We need to find out. I don't, yeah.
What is a napkin ring? I don't know. I don't really use napkins.
Yeah.
I just use my
Because
tie.
are we finding that little part?
You got it better.
Yep. It's also helpful in carrying hot things.
So we
I
convert
just carry hot things in my tie.
2 millimeters.
So this is the volume of silver needed to create the napkin
If
ring.
we only
So-
use this part.
So that means what it is you need to calculate this tiny little volume.
Only finding this part.
Because the silver is what creates that little ring.
Okay, so what you would do is you would find the big cylinder and then subtract the little cylinder.
Right.
Very
This
good.
little piece.
Yeah, very good.
Okay, let's start with, but we know that.
Find the big thing. Subtract the big thing.
Which is 20 millimeters. And the height is 2.2. So we have to do 2.2 the height. Yeah, I guess you could just find it by using that 2 millimeters height. So,
No, we did a whole thing. Yeah, these little diameters are.
okay, all right, so this would be height 27 millimeters. 20 millimeters.
Where's the 0.2?
You're adding it to add, if you convert it to.
You're adding it.
So when you take cylinders, you take it and you.
Yes, ma'am.
Okay, so I just realized. Okay, so it gives us the length of that outside cylinder. So we just have to find that and not do all the extra stuff, right?
What extra stuff you talking about?
Well, finding this back in and subtracting it from this, because we have.
But that's just a length. You need a volume.
So yeah, we take the length and we take the height and we find the radius.
Then do it.
Volume of it. Would that work if we don't have, if it's not like a whole like solid shape?
Absolutely not. Because your equation only works for a cylinder, right? Yeah. Your original idea was promising though.
The radius would be 2.
Just know that the inside cylinder and the outside cylinder have different radii, right?
Right.
That first idea was very promising.
Yeah. AH minus. The height would also be 20. Yeah.
Then you subtract them.
Radius 1 equals this.
Because we're just trying to find this little part. So we found the big part and then we found the
Because 20 millimeters plus that 2 millimeters.
You have to add these together.
Shouldn't that just be for this big part?
So you find that. and that's
Like,
where you
if
get
you're saying this is 2 millimeters, if you're doing radius 91, this little, it's this one. Yeah, so radius is 2 this.
Oh.
Yeah, so, but instead of finding the area space, you're finding the whole big circle.
Which is the same thing every year.
Oh, so we're taking the circle out of there. Yeah, we're separating the cylinders all together. We're having one separate cylinder and then one big.
This
Oh,
is, it's the tracking, this formula is the same. We did a both.
always back. 3 to 5.
That and more interesting.
You're stupid, yes, because what if to round it up
Use the time.
The height of 20 versus- I didn't even take a picture of it. Right? Yeah.
Wait, what were you, sorry? Yes. 15 millimeter. 3, 1,520.
You're okay.
Or well, 5.
Feel bad.
Because that's what we
Pi 22
We
squared.
found the, if we found the full volume, it's just that, but we have. That's why I just.
Not if you're finding the area of the base.
Oh, right.
On A2, .76. Oh, I haven't found it.
Yes, ma'am.
Yeah.
With comments, bro?
Oh, I'm on Pi. I'm not.
Anytime I
But
look
I
at
was
my
surprised.
Eric's like, I'm here for this. I was right, no, that's why I was like, just tell me.
Can your buddies do it?
He didn't teach me. He didn't teach
Just
me.
be like, versioning to Hannah's, assignments. If you don't mind emceeing your grades. There you go. So it doesn't matter, right? Your other option is to just wait until your phone gets back and I'll enter them then.
Can you wait that long? Like next
Yeah, why not? Yeah, go with the flow. Yeah, I'm pretty chill. Yes, ma'am. You go. Good work. Good work. Good work.
Thank you.
What?
I shouldn't have given y'all the volume of a cone done like 5 minutes.
Oh, no, I don't think that's. Yeah.
Here you go. Good work.
These are the extras.
Oh, thank you.
She said, yeah.
That would be it.
Good work. Well done.
I have a negative number.
Yeah. Oh, yeah. She'll get a negative.
Yes, ma'am.
Area 1. Oh, because we did the big one second. That makes sense. So these are just area. This is area 2. So we do figure it out. So like how did we go that whole time doing that? What's wrong with it?
5,275.
Growth mindset. I love it. I love it. I have not gotten any better, which is not. Bro, I think okay, it would be. I'm gonna be 8. So I feel more confident in my homework because that's how. No. I want to go. First, I'm gonna find my calculator. Oh my gosh, guys. I've been proud of you. Never. We are twins. One thing I'm go back. I will. I can draw it. She's like, plus 2 points for art skills. Or each.
All the way to measurement 6, so I need to go 7, 8, and 9.
Science actually. Basically, shut up. There's something wrong with my voice. This is not being able to go that deep.
Hello.
Hey, Deja. My breath is so bad. That's the high. Oh, I'm just at 8.
Course materials. That's right. I need 7, 8, 9. Yes, ma'am.
For this, I was thinking that I could just cut this in half and then subtract this from this, but the radius was different. So you
Correct.
can't do that.
So let's see. Let me read this. A cone-shaped paper water cup has a height of 8 centimeters and a radius of 4. Okay. If the cup is filled with water to half the height, what portion of the volume of the cup is filled with water?
Oh wait, that would be, yeah, that would be this part.
Yeah. So think about, what does a cone look like when it's flat?
But you didn't divide it by 3. Yes, I did.
Close.
Why do you have to find that? What is that?
What does a cone look like when it's flattened?
Okay. And so pi, it would be 2.5. So it's pi.
So it's no longer a cone anymore. I flattened it. So what is this now? Yeah. Think about the problem like it's a triangle here. What was this full radius? Or what was the radius of the cup? So this amount is 4. And it says the height was what? The whole height was 8. Okay. So you can set up this right triangle. Right? This is 8. This piece is 4. You can compute this piece, right? But then it's saying it's halfway full. So to half its height. So then you can construct another triangle where if this total height was 8, this would be 4. Okay. And then over here, you still don't know this. This is an unknown and this is an unknown.
Huh?
But you can use properties of similar triangles here. So this whole thing is 8. This piece is a 4. This is a R. This whole thing you can figure out, right? This whole thing you can figure out.
We are.
What you aspire to find is,
Yeah, I agree.
what is the question? Does it want this distance?
I'm not trying to blow.
Well, I thought that if I found that radius, then I could find the volume. And then,
Oh yeah, what is the volume? Right, if you can find that radius, then you can find volume, yes. So this is the key here. We want to know what this right here is. So how could you do that? Are you familiar with similar triangles?
what do you mean?
Okay. So here's the concept of a similar triangle. So let's say I have a triangle like this. This is A, this is B, and this is C. If you can create a smaller triangle inside that triangle,
That it would, go ahead.
let me call this whole thing capital B. Let's call this whole thing capital A. Let's call this whole thing capital C. Then this would be little c, little b, little a. So similar triangles says that the ratio of A over B is the same thing as the ratio of capital A over capital B.
So, would it just be 0?
So this is saying now that this larger triangle, this ratio 8 over 4 is the same thing as the ratio 4 over your unknown. You can solve for that unknown. Yeah, cross multiply. So this is 8 question mark is equal to 16. So question mark is equal to 16 over 8.
So then, but I'm doing it right, right? Like that'll, it's saying what portion of the volume of the cup is filled with water. So I didn't even use that.
Well, you're supposed to, now that you know the R, the new R, the R of the water, you can calculate the volume.
Yeah, just,
Yeah,
so I didn't even do that, 'cause that's the whole thing.
that's okay.
Yeah.
You can just alter it to just the water portion. Oh, wow.
Hello.
3 hands up.
It's all for the same question.
Okay.
The first escape, the one that you just, I was trying to listen to how you explained it.
Oh,
Wait, shouldn't you just find the area of the cone and divide by 2?
no.
Why not?
First of all, it's a volume problem.
That's what I said.
Second of all, it's not as simple as just dividing by 2. It's just not. This is reality.
Oh, I felt like
It's like, why is this table not a chair? It's just not.
So
No.
you could sit, I understand that you.
Yeah. Okay, so over here, maybe you guys should come here and see it. You need a homework?
Yes, please.
Good work.
Thank you.
And does your colleague need a homework? Okay. So here is your, so it's not the cone anymore. We flatten the cone. And it turns into a triangle. Okay. So then this height is 8. So that translates to the height of this triangle.
So there's 3 different triangles. And
2 different triangles.
Yeah.
It's a triangle within a triangle right here. So then this water, it's half of this length right here.
Yeah. So then it would be 4.
4.
So then question mark.
Question mark is what the radius we started to find. It's the radius of the water cone.
Okay, so if you have 2 triangles, then it's 8, then it would be 16.
Yeah, so you set it for proportion.
2.
You set it for proportion, you say,
Bless you.
Thank you.
8.
Why are you laughing like that?
That's pretty funny, I'm gonna lie. Okay, so
Wait, I'm just.
8, this ratio, divided by this ratio, is the same thing as this ratio divided by that ratio. It's a similar triangle's proportion.
I hate to ask you this, but can you draw this again?
Yeah.
Can you go? No, I need to know how to do
Yeah.
this.
I could draw it again.
Thank you. Gotta start over.
Yeah, I can see why you want that because the whole process of drawing it out is what like.
So you cut the
makes it make
shape in half. Yeah. You find the area of that triangle.
Yeah, you had a cone, but if you flatten the cone, it turns into a triangle.
So then you find that triangle, and then you use the radius that you find to find that new circumference.
No.
Circumference.
Yeah,
That's a
where's
circle.
circumference coming from?
I don't know.
So what's the height here?
The height is 8.
8. So in our picture, we'll write that this is 8. What's the radius?
4.
So, okay, in our picture, we'll write that this is 4. So when my graph looks really cluttered, I like to create another one that's more simple. I don't want to get distracted by this whole thing. I just want to see what is the essence of this thing.
Okay, so the height is
So this is a triangle.
Yep.
This is 8.
And it's
This is cut in half, so it's 4.
4.
4. And then this is still the radius, so this is still 4.
Yes.
So you have a triangle within a triangle so that they're similar triangles. When you have similar triangles, you can say that the ratio of this, of the larger triangle, divided by this, of the larger triangle, is the same ratio of this smaller triangle, divided by this unknown. So this over that, tiny this over tiny that.
Okay.
That's just the concept of similar triangles.
Wouldn't it be 2?
Yeah, when you solve for question mark, it becomes 2. This is I mean, have you guys learned this stuff before?
Yes.
Yeah,
Oh, I have.
yeah, I don't know why they're asking this problem because it kind of requires for you to know how to do this part.
Okay, then
So-
what? Is that it?
No, so when you find question mark, when you cross multiply, that becomes 8 question mark is equal to 16.
Question mark. No, but all that jumps. Question mark.
So that's the radius of the water cone.
Okay.
So that's not the answer.
So
We're talking about the volume here.
in the end, you'd have to multiply that by 2, right? So now we're gonna just be
No.
working with 4.
No, because it's just the radius. We just found the radius. We want to know what is the volume of the water
Yeah.
cone.
Yeah.
And then we're going to transfer this into cone world. Yeah, go from 2-dimensional projection, which creates a triangle, to 3-dimensional cone.
So do we just need to worry about this now, or do we still have to worry about this?
Just this.
Okay,
Yes,
so
ma'am.
that's all we're worrying about now.
Yeah, because the question
So we have
says.
4 and 2, so we have our height and our radius.
Uh-huh.
So volume equals AH over 3. A is pi r squared.
Mm-hmm.
And so our radius is 2.
Mm-hmm.
So we plug it in, and then our height is 4, and then we do whatever we have for A times H over 3. Yeah.
Yeah. So it's 1/3 pi r squared h. 1/3 pi times r radius 2 squared times our height 4. 4 times 4 is 16 divided by 3, so it's 16 pi over 3.
That's the answer?
Yeah, that's the volume of the water cone. Is that what it was asking you for?
Yeah. So why don't you multiply?
I don't think that's exactly what it was asking you for.
It sounds like that's what it's.
Wait, where's the question?
Give me a
I see
second.
it.
Give me a second. Oh, this is the homework.
Well, it has to find the volume of half the water thing. So that's why I thought you guys.
Okay,
What would be the
so
water cone?
if the cup is filled half of the height, what portion of the volume of the cup is filled with water?
Yeah.
What
Half of it.
portion?
What is that?
So what is the total volume compared to this volume?
So
thank
we
God.
have to find the volume of this.
The bigger,
volume of this,
the whole
subtract-
volume.
Subtract them?
Basically to compare them.
So you divide it by 2?
So if the cup was fully full with water, what portion of the volume is 100%?
And if it's not, you just divide
What?
by 2 and get half.
That would be like 50%.
I'm confused.
But you need to calculate it. You can't just say, oh, it's half the water, so it's
So
50%.
it's this right here.
So we get the water cone is 16 pi over 3 is equals volume of water cone. What's the volume of the total cup, the big cone?
It's 1507.
1/3 area height plus 1/3 times pi r squared h. That's 1/3 times pi times the radius. 4 squared times the height.
8.
Aha. So this is 1/3 pi times 16 times 8. Ooh. What's that? 80 plus I can't do that in my head.
80
36,
plus 56.
42,
80 plus 48
48. So 80 plus 48.
is 128.
This is the total volume.
That cashiering job's coming in handy. So
So we
then,
got a calculator.
uh,
They're
so
everywhere.
how do you, whenever you have like it in pi form, how do you put that in the calculator to subtract that?
You could just type in 3.14 every time you see a pi.
Okay, so we'll do 16 times 3.14 over 3 and get that answer. And then 128 times 3.14 divided by 3 and get that answer, and then subtract.
So that would say, that would find the difference. What you want to find is what portion of the cup.
Okay, but
It's
what
filled-
does that word portion mean? Like, what are we?
Now I can explain that. Okay. I need some more space.
Ah!
This- Yeah, try tripping on that. I keep tripping on that thing. Mhm.
It's okay.
It happens. So over here,
I'm a little clumsy sometimes.
so it's the total volume divided by water cone volume.
TV. Oh, is it kind of like a radius?
Just the ratio.
Ratio.
Yeah. So if you want to make it a percent, you multiply it times 100%.
Okay.
But if
So-
you don't want to make it a percent, you can just leave it as total volume divided by water cone volume.
And that would be the ratio.
Wait a second.
After. No.
I
You just flip it.
flip it. Yeah. Water cone volume over total. Yeah.
So we just need to find the volume of both of them.
Yeah.
Which
and
we
we
found
did.
the volume, but like if you want to simplify it.
Here's the water cone. Here's the total cone.
All right, perfect.
Does that make sense?
Yeah, somewhat. Okay, how does this triangle relate to this?
It's squished take the cone and squish it.
So, where's the equation when we found that code? Right here?
Mhm.
1, 2, 4. That's how we got this?
Yes, ma'am.
Okay.
Do you have any questions? Okay. Is there anything else you need?
Yeah. So I got. I have the thing, but I don't know if I can tell. Thanks.
Yeah, you're okay.
Oh my God. This is why you're just yeah, I got 200. Oh, I did 68 wrong though. I was like, I got 12.50, yeah. Or 68? Yes.
Okay, so
Yes, ma'am.
when I simplify it down, sorry, there's a lot because I ran out of space, but the 16 pi 3 is 1674, 128 pi 3 is 133.79. So I put them and then I multiply it by 100% and I move the decimal two places. So would it be 12.5?
Yeah.
Okay.
See, it's not 50%. You see that?
Right.
Just because you have the height, it doesn't mean it's 50%.
Because there's a smaller and then it goes.
Yeah, it slants. Because of the slant, it alters it. Maybe if it was a cone or a cylinder, and you would half it, right? If it was cylinder and then you only put half the water there, it would be half. But the cone, it's not necessarily true.
Yeah, my five all over the place. No, yeah, I don't know. They just like the notation on that one. You're not supposed to.
I'm 67. I'm sorry, no, that's 196.2. What's number 68? I thought you said a really weird number, and I was like, how did you get the portion? Divide the big. So I took the water volume, and the big volume, and you just divide it, and I multiplied it by 100. I put them over each other, and then I multiplied it by 100%. Oh, pretty good. That was so good. I was nervous. Oh, I was like good. It should have been here. Why can't I not be here? It'll be easy. I just have to think. I'm like trying to.
Yes, ma'am. Absolutely. So,
Over number 7. It just moved. I'm seeing where that. Yeah, that's the right. That's where that one is.
Oh, actually,
That's the
that's
answer.
gonna get your radius by going backwards with this, right?
Ooh, show me. Show me what you mean.
Oh, yeah. It's like really close to that.
I don't wanna say.
Does it say entrance numbers or we just?
It just doesn't say
number.
There you go. What are you solving for here? Uh-huh.
Very rare. I don't know what that is, but I like pretty much everything.
Uh-huh. Then once you find out, where are you gonna put it?
In place of R.
Mm-hmm.
And this part of the problem have anything to do with finding the volume?
Is that part of the problem?
Yeah,
Yeah, because that's the volume of a sphere's equation.
So then, okay, so I got, kind of looks like one degree with this. So do I just, I don't know how to keep it.
They're the same.
Oh, is this problem is the same as this?
Yeah, they're all equivalent. Volume is
So I
equal to
don't,
all.
so I don't have to plug it into this, right? I pick either one.
Yeah.
Oh, okay, alright.
Mhm.
Now I'm working on 69. That's the diameter. Whoa. I think. But it's just so strong. I mean, I take a picture of my Oh my gosh. Oh, and then I use this thing. Problem right here. Wait, what the heck? Oh, never mind. So this is the equation we use to find the volume, right? Wait, we still have one.
Surface area.
I got one.
Boom. That's beyond. So
Yes, ma'am.
she wouldn't learn something.
You're learning something. Well, that's what you're paying thousands of dollars for.
The first time this is
Now you're
happening.
reminding me.
Yeah.
So what? Oh, you just calling me over to say thanks? Oh, you're very welcome. You're the one who's learning. I'm just guiding you. So thank you for learning.
Yeah.
Because the success of my students directly influences how I feel like I'm doing my job.
Now, when you get my test grade back, don't feel discouraged.
I never give up on anybody.
Just my brain.
I never give up on anyone.
My anxiety times, always look at numbers on the paper.
I will have a talk about what grades are and what they mean to me when we talk about grades. I'll let you know what I think about grades. I don't think too highly of them.
Wow.
They don't imply whether you'll be successful in life or not successful.
So we all get 100.
Also, though, find the surface area of
Oh, I was thinking of the same thing.
No, but how do you?
Oh,
yes.
Yeah, it says it's 4
I don't know how to do this one. No, but I just.
pi r squared.
Or is it just the 4 pi r?
It's just a 4 pi r squared.
I'm sorry. Not times r.
No, it's just 4 pi r squared. It's very interesting because the area of one circle is pi r squared. So it seems like the area of a sphere is the same as the area of 4 circles of the equivalent radius. It's incredible.
I don't know how to do this one.
Yes, ma'am.
Circumference is 2 pi r 6. That's all pi r.
Gotta love how you guys are always having fun. Never change. Never change. Accents are funny too. I don't know if that's like Russian or
We don't know. It's
Lebanese or I don't know what that was. Okay. This one,
No, yeah,
Plant?
36 pi divided by.
oh, okay, that's kind of cool. Let's see here. A plant stand is made of a shape of frustum of a cone chunk block. Find the amount of material needed to make the stand.
8 poles or something? No.
Mm.
Did you get one?
So you're saying you want to extend it and make it a full cone?
I mean, that's only
Radius for 7.
Oh, yeah, and I did 30.
Hmm.
I got 1.78 for the radius.
Yes, it's 9. I did 36. No, it's not.
I got 3.1.
That is a way that you can do it.
How would you do it? I don't know if it's hard. Square root of 6.
Oh, like, I did like,
You don't have to write it down.
So yeah, bring that over here. I need to look at those numbers. You can just hold it for me. You can just, all right, so yeah, it's gonna fall. So over here.
Work it out. Put your number and then pi r squared.
Okay.
That's how you square root of r squared.
Boom. It looks like a what? A dog cone, yeah. So this is 60 centimeters, 100 centimeters. So actually, why don't we extend this? And to honor your idea. That's a great idea. If you ask me, I think it's a wonderful idea. Let's extend it because we can find this volume by saying, what's the total volume? Okay. So now we have this thing right here, but we don't know how high this is, this blue H. But do we know how high the black H is? 40 centimeters.
Yeah. Okay.
Could you do this like 100 over 60 and then this over 5?
Oh, you are saying, let me apply what I learned beautifully apply what I've learned here and say, projecting this into 2 dimensions becomes a triangle like this. This is 60, this is 100, this is 40, but this is unknown. So unknown over 100 is equal to what over what? Close. See, you want to compare the larger triangle to the. So actually, this isn't wrong, this way of thinking isn't wrong, but there's this triangle, then there's the larger triangle, right? So this is some unknown little h. So we want to say little h over 60. This over that is the same thing as total unknown over that. So there's two unknowns. So we can't solve it yet. With this information, we can't solve it yet.
Like, just do like a ratio, and then this.
So you're saying 100, oh, yeah. You want to make a ratio over 100 with 160? You can't because 100 corresponds to the larger triangle and 60 corresponds to the smaller triangle. That game you play only allows you to make correspondences between one triangle and the other that it's similar to. So this total height unknown, maybe call it capital H now. Notice that capital H is equal to little h plus 40. Do you have any equations about cones that you can use here?
Okay, cool.
Remember in your handout, you had some equations about cones?
Yeah.
You had like the lateral length, you had the height, okay? So what would be the volume of the larger cone? Capital V would be the volume of the larger cone. Little v would be the volume of the smaller cone. The volume of the larger cone is 1/3. What?
One-third area, right?
Mm-hmm. Big area, capital H, right? Volume of the little cone would be what?
I'm probably not able
So I'll call it little a, little h. Okay. So we know,
Are you saying, yeah,
yeah, so little a forms this with this radius, this area, pi 60 squared. Capital A is this area, pi 100 squared. So this is running out of ink, so we can run that calculation real quick. So this becomes 1/3 pi 60 squared h. This becomes 1/3 pi 100 squared capital H. Where capital H is equal to this. Oh, it's just not squared, it's just that.
Would you what?
but you still don't know. You have two unknowns.
Yeah, you still have two unknowns.
Is there any way to do it without extending it?
Do you know what the area or the volume of a frustum is? Well, yeah, I guess you can look it up. But is there a way to derive it?
Yes, actually.
That's my friend.
The, I know. Like how much you can.
Yeah, I got a soul one.